Hi, this is the third lesson of topic 6 on radioactivity. And in this lesson, we are going to learn about the different types of radiation when considering radioactive decay. Now, first, what is radioactive decay? To actually understand what it is, let's consider this GIF. When looking at this, I want you to think, what's happening here and why is it happening? Here we can see that the chair is breaking because the man is too heavy for it, and as a result, the chair is unstable. Radioactive decay is similar. Radioactive decay is the random, spontaneous breakdown of a heavy and unstable nucleus, resulting in the release of energy and matter from the nucleus. And as a result, the resultant new products of radioactive decay are more stable. It's a bit like popcorn. It's random in the sense that you don't know which nucleus, or in this case, which popcorn kernel will decay. It's unpredictable because you don't know when it's going to decay. And it's also spontaneous in the sense that when a nucleus starts to decay, it can't be stopped. Now we know that as a nucleus decays, it releases energy and matter. But what exactly is that? Now this table is going to sum up all the content you need to learn from this lesson. First of all, there are 3 types of radiation we need to learn about: alpha, beta, and gamma. And for each type, we're going to learn about the symbol, what it is, the charge, the atomic mass, the speed, the ionizing power, and the penetration power of each. So, here we have alpha, beta, and gamma. The first thing you can notice is the symbol of each. Alpha particles are like a bowling ball, extremely heavy and relatively slow. Beta particles are like a ping pong ball or a table tennis ball, much lighter, but also much quicker. And gamma radiation is like light. It has no mass and moves at the speed of light of 300 million meters per second. Now these are examples or analogies we can use to understand alpha, beta, and gamma radiation. But in actuality, an alpha particle is a helium nucleus. A helium nucleus with 2 protons and 2 neutrons. As it has just 2 protons and 2 neutrons, it has an overall charge of +2. A beta particle is simply an electron. And gamma is part of the EM spectrum. Based on our chemistry knowledge, we should be able to fill in the first 4 rows of our table. Pause the video and try and fill it in. So, you should have seen that the symbols for alpha, beta, and gamma are like so. Alpha particles are a helium nucleus. Beta particles are electrons. And gamma is part of the EM spectrum, so it's an EM wave. As it's a helium nucleus, alpha particles have a charge of +2. Electrons, as we know, have a charge of -1. So would a beta particle. And gamma, as it's simply an electromagnetic wave, does not have a charge. In terms of mass, a helium nucleus has 2 protons and 2 neutrons in its nucleus. Therefore, it has a mass of 4. Beta particles are electrons and have a mass of 0.0005. And gamma, as it's simply an EM wave, so like light, it has no mass. Let's take a look at the ionizing power and the speed of each of these types of radiation. So, when considering ionizing power, consider an alpha particle like a bowling ball, a beta particle like a table tennis ball, and gamma radiation like light. From this, which one is going to most easily knock over this bowling ball pin? As you can imagine, it would be the alpha particle. The alpha particle would be the most ionizing in knocking off and hitting this pin. Next would be the table tennis ball, and finally, our light would have little to no impact on this pin. So when considering the ionizing power of alpha, beta, and gamma, we actually consider the ability to remove an electron from an atom. So in this case, an alpha particle would be the most effective in removing an electron, then a beta particle, and finally gamma. Now pause the video and try and fill in the rest of the table. Let's fill the rest in. Alpha particles are very slow. Beta particles are still slow, but faster than alpha particles, and gamma is very fast. In fact, it's 300 million meters per second. Now let's consider the ionizing power of each of these. Alpha particles are very ionizing. Beta particles are ionizing, but less so than alpha particles. And gamma is not ionizing. Now let's try and fill in the bottom row about penetration power. Now, here we have a similar situation to what we saw before, but we have a fence blocking it. You can imagine the bowling ball will not be able to pass through this fence. However, the table tennis ball and the light will easily pass through. Based on this, we can say that the alpha particle, or the bowling ball, isn't very penetrating compared to the beta particles and gamma. So as this kind of fence would stop a bowling ball, paper can stop alpha particles. Now let's take a look at this kind of fence here. Again, the alpha particle would clearly not be able to pass through this, and neither would our ping pong ball. But our light would easily be able to fit through this grating. So just as this fence here would stop a bowling ball and a ping pong ball, alpha and beta particles can be stopped by a thin sheet of aluminium foil. Now let's take a look at one final example. Here we have a brick wall, and the brick wall would simply stop all three, including the light. So just like this, alpha, beta, and gamma can be stopped by a thick sheet of lead. Based on this, try and fill in the table below. Have a very low penetration power, as it can be stopped by paper. Beta particles have a low penetration power and can be stopped by aluminium foil. And finally, gamma has a very high penetration power and can only be stopped by lead. Or concrete. That's it for this lesson. I hope you found it useful. If you have any questions, please do ask.